quantum physics, and it goes through important calculations as well as facts about excitation. So just a reminder, excitation is when an electron gains energy and moves up an energy level. So just starting off with this question, it says an electron is incident on a hydrogen atom. So these are the energy levels of a hydrogen atom. This lowest energy level, we call that the ground state. That's the lowest energy level that any atom can have. And it says that when an electron strikes an electron on the ground state, it will excite to the n equals 2 energy level. Excitation just means it gains energy to move to a higher energy level. The atom then emits a photon of characteristic frequency. What does that mean? Well, if something excites, shortly after it actually de-excites. But that difference in energy, it doesn't just disappear, it's actually released as a photon. So that's what it means by emits a photon. Okay, so explain why the electron in the ground state becomes excited to the n equals 2 energy level. Well, this electron becomes excited because it absorbs energy from the incident electron and it uses that energy to excite itself, so to go up an energy level. And so I just want to write this in text form just because I want to summarize everything clearly. So we say that the electron in ground state absorbs energy from incident electron. That'll be 1 mark. And then if you want to go further, you can say that, well, it absorbs an exact amount of energy, because if it absorbs more than the energy that's needed, then it won't excite. Or if it absorbs less than the energy that's needed, it won't excite. It needs to absorb that exact amount of energy. So that second mark is for mentioning that that exact amount of energy has to be absorbed. And we can actually find that exact amount of energy because it's told us the units, electron volts, and it's told us the values of the energy levels. If we find the difference between these two values by doing 13.61 take away 13.6 take away 3.41, that'll get you 10.19 electron volts. So exactly 10.19 electron volts is absorbed by this electron from this incident electron, causing it to move up an energy level. Now part 2, it says calculate the frequency of the photon. So we mentioned the photon is emitted when de-excitation happens. And we're going to use equals HF to do this question. I'm just going to change the pen color. We know the energy released in the photon because during de-excitation, the energy difference is difference between these two, which we found is 10.19 electron volts. But we have to convert it into joules in order to use it in our calculation of energy. To convert into joules, you multiply by 1.6 times 10 to the minus 19. And then you make that equal to H, which is 6.63 times 10 to the minus 34, multiplied by frequency, which we're trying to find. Divide both sides by this value here, and you'll get that the frequency, I don't really have much space, I'm just going to write out the frequency, is equal to 2.46 times 10 to the power of 15. And of course, that's measured in hertz. 15 hertz. Great. Let's move on to this part here. The initial kinetic energy of the incident electron, this electron that's coming in, is this much. 1.7 times, that says 10 to the power of minus 18, by the way. I'll rewrite that out in case you couldn't read that. Times 10 to the minus 18. Great. Calculate its kinetic energy after the collision. So if it comes in with that much kinetic energy, well, that energy either goes into exciting this electron or goes into the remaining kinetic energy that that electron has after being excited. And that's where this equation comes from. So we say that the amount of energy that the electron comes in with, which is given to us in this question, is equal to the energy needed to excite it to that energy level, which is, well, we found that that's 10.19 electron volts, which we then converted into joules using this. So I'm just going to write all that out. So this is the energy needed to excite the electron on ground state, plus the kinetic energy that the electron has after being excited. That's what we're trying to find. I'm going to write that as EK, which is just a subscript for kinetic energy. Taking away this whole value from both sides of the equation, we get that the kinetic energy is actually just equal to 7 times 10 to the power of minus 20 joules. So that's your final answer here. Hopefully that made sense. Show that the incident electron cannot excite the electron in the ground state to the n equals 3 energy level. Well, let's think about how this could be. We know that the incident electron comes in with this much energy, because actually I'm going to highlight this. It comes in with this much energy because that's what we were given in the question. But we want to show that that's not enough to excite an electron that starts off from ground state all the way to n equals 3. So how do we show that? Well, let's find the energy difference between n equals 1 and n equals 3. So first of all, 13.6 take away 1.51. The difference between these two energy levels is equal to 12.09 electron volts. Now, if we convert that into joules by multiplying by 1.6 times 10 to the minus 19, that will get you a value of 1.9 times 10 to the minus 18. And we can pretty much stop there, because if this much energy is needed for an electron in the ground state to go through the n equals 3 energy level, but it only gains this much, that's not enough energy, because this number, the energy that's needed, is more than the energy that's provided. So hopefully that made sense. If you liked the video, please leave a like, comment, subscribe, and if you have any tutoring inquiries, just send me an email. My email is linked in the description, and I'll try to help out as much as I can. I'll upload a new video tomorrow, so look forward to that. Thanks for watching.